to introduce myself very quickly. My name is Thorsten Pottebaum. I've been working in the medtech industry in a number of different roles, as a chief information officer for a manufacturing site, within the strategy and planning function as an enterprise architect, and lately I'm responsible for the audit program of the worldwide company. So I would like to start actually with this Blockchain 101 with the introduction with a statement or a quote from Ken Olsen, CEO of Digital Equipment. And he said, "There is no reason for any individual to have a computer in his home." And looking at the reality, how it is today, how wrong was that viewpoint? So the question which comes out of that one is, why are these radical innovations tending to surprise us? And asking seriously, why do we need blockchain? So blockchain is effectively enabling three elements. It's enabling trust. It provides recording and managing of the truth. And it is a means to exchange value. And all three of them are actually keys for modern societies and economies. So the basic underneath is actually systems of records. And systems of records have a number of criteria. There is the ability of time stamping. The recording in itself is immutable. We have the ability to deal with identities and credentials. And last but not least, it's shareable and verifiable. So there have been innovation milestones in the systems of records. The origins were effectively tools and processes to record the values and events, and then became more and more sophisticated. We initially started with books. And paper and ink simplified actually the recording, and that was the merging of bookkeeping as such. And then the next leap in itself was actually given by the computer and the internet, by the ability to do that in a digital way, by using databases that was increasing drastically the speed and the efficiency. And the internet as such then was giving the ability to exchange this data almost seamlessly. So the book, just a quick view on that one. The starting of the double entry accounting, or as we know that today, the bookkeeping, and that dates back to the 15th century. And then it took quite a while, but then the computer and the internet accelerated things quite dramatically, as mentioned already before. It became more efficient. It speeded up the way of processing, and communication and itself became seamlessly through the internet. But the question which kind of is still out there is, what is the internet? What is this form of communication yet not providing? And there are mainly three elements. The internet in itself doesn't provide an identity. The verification of identities of someone who rightfully has the ability to create a record is not part of the internet technology and requires additional methods on top, and we alluded on that one already a little bit. Then the transfer of value, the transfer of property in itself is not embedded in the internet as such, but it needs additional applications to record that and to keep that. And the last thing in that context is the exchange of the information itself is not necessarily immutably. We're trying to do that by using cryptography, but it's also not transparent who communicated and which these two parties are, and these are causing problems even today. So these problems in itself introduced by the computer and the internet is something which pretty much all of us experience on a day-to-day basis. On the identity side, we have a number of accounts, we have a number of identities, we have a number of passwords, and all of them are different, and we should keep them different to keep things secure, but it is kind of a pain point in the usage. Then the ownership of property of value has to be recorded separately, and these layers which are on top of the internet are often vulnerable and causing issues. The banking industry kind of was the first who suffered cybersecurity attacks in that context. And nowadays, that's kind of a general issue which every company has to deal with. And the last but not least, again, there is not a single point of truth. Transparency in itself is fragmented, and that leads actually to siloed and often incorrect information, which needs then quite a significant effort for clarification and identification what is actually the truth. So when we look at this from the way a global business would handle that, we have initially had a number of records which were kept by all the participants effectively in that system. And the arrows here symbolize actually the efforts to synchronize effectively these different systems of record, these different ledgers. And as you can see, that is quite a significant communication effort which is related to that. So how did we try to improve that? Through digitalization, through the first phase? Well, we centralized a lot of this communication into central platforms, into software as a service solutions, and made them accessible effectively for participants in the system. And we're hoping that by doing that, the communication in itself got streamlined. And the reality is, it probably did. Where it falls short is there is not one centralized system which everyone is using. So we again have a number of different systems as a participant in the market, which we have to interact with. So how can blockchain in this context help? It's actually a combination of both, in the way that we have a distributed ledger technology, which actually through the technology allows a copy of the truth and the records in proximity to the participants, as you can see here. And the synchronization of this ledger in itself is part of the underlying technology. So the communication in itself becomes a lot easier because it's part effectively of the technology which enables that. So what is the prerequisite, or what are the underlying technologies and innovations which made actually blockchain possible? First of all, it's clearly the digitalization of information to bring it from paper and ink effectively into an electronic form. The second one is the abilities and capabilities of cryptography, which allow as a cornerstone the secure adding of information to a blockchain. Then the third one, game theory, which is the strategic behavior of participants in a system and the way kind of this behavior would show itself. Computer performance as such increased dramatically. If you look back 10 years ago, the performance, or 20 years ago, the performance of a computer is not to be compared to what we kind of carry around as a mobile phone in our pockets today. So the increase in the performance of computing power in itself also enables the usage of distributed ledger technologies and computation effectively in proximity to the participants. Then on the topic number 5, we went through the phases of Web 1.0, which actually were the beginnings, where a website was quite static, and then kind of bringing dynamic content into that with Web 2.0, and we're talking with blockchain about Web 3.0, whereby applications in itself are then also logically not centrally provided anymore, but become effectively available through the blockchain in the proximity to the participants. And the last point is effectively the involvement in consensus methods, which kind of assure that transactions which are included in this ledger in itself are rightful and are identified as valid. So how does it basically work? So there are some features, and by no means is this list a complete list. It's just picking up some of the elements or core elements which we would have to look at. First of all, the data is stored and updated on a decentralized node. So we have effectively a network of nodes where the data is stored. And due to this replication of the data to the participating nodes, we have effectively a distributed systems and a number of copies, which is quite quickly leading effectively to the topic number 2, which means immutability. There is a high level of transparency through the fact that there are copied of this ledger throughout the nodes. To actually change entries on the ledger would mean that I at least have more than half of the nodes under my control and at one given time. And that is actually, depending on the amount of nodes which are taking part in this blockchain, normally quite hard to achieve. Then we said we need timestamping as a part of the record. The blockchain technology is providing that. We have consensus mechanisms, which I just mentioned already. And nodes in the network have to agree effectively on the validity of a transaction before it's actually added to the blockchain. And that makes it actually also quite secure. Through advancements in the technology, we now have the ability to have different levels of anonymity within the blockchain. There are technologies like so-called zero-knowledge proofs, where I actually just prove the validity of a statement without knowing the underlying data. That is similar to, for example, an age verification, where I have to verify whether the person is over 18, and the answer to that one could be yes or no, without exposing, for example, the birthday of the person as such. And blockchain technologies are enabling this, which is giving an ability to verify data in a different form than we have done that before. It's very secure. The reason for that is the data in itself is encrypted, and encryption in itself is verified by multiple nodes. So there is a multi-layer resistance against tampering and hacking attempts. And the last topic, and that's one which kind of came into a number of blockchains more in the later phases, the later generations, is the ability to be programmable through so-called smart contracts, which enable then the automated processing depending on events of data and the transfer of data, and therefore we can automate processes as part of the implementation on the blockchain. Just very, very quickly, a number of terminologies which I might have mentioned already, but just to give the background. Web 3.0 is actually the next phase of the internet, and that will give an increased level of decentralization, security, and it will empower the user to control the experience a lot more than before. So, for example, the ownership of data, which is kind of one of the major problems at the moment when it comes to data privacy, is a topic which can be also addressed with a technology which is provided by blockchain. Then we were talking about DLT, or distributed ledger technology. I think that is kind of understood now. It's kind of a database which is distributed over multiple parts, so-called nodes. And every node has a copy effectively of the data. So we are creating actually a shared ledger, which is updated in real time between all the nodes, and the protocol in itself underneath is providing that. Blockchain as such is a specific type of this distributed ledger technology, and that creates an immutable and transparent layer of transactions, which are shared then in this network of computers. And one terminology which actually becomes quite central also for the usage is the ability to use so-called decentralized digital identities. So far, identities in itself are normally controlled by someone. So, for example, if you are using an application, you have to have a username and a password. If you don't want to use that individually for every single application, then the next evolution of that one were federated identities, but still the control over this identity was with one specific entity at the end of the day. So for example, if you're using Google to log into 4 or 5 different accounts, you're pretty much in the hands of Google, and they are collecting also data about you by doing so. And this next evolution is actually decentralized digital identity, which brings then the identity and the data and control over the data of who gets access to what kind of data back to the user. And quickly, another 4 of these terms, private versus public. There is the ability to run a blockchain effectively within a corporate environment as a private or pseudo decentralized blockchain. It's then in that context obviously centrally owned by the entity, and that is in contrast to a public decentralized blockchain, which is actually managed by the public nodes which are participating in the blockchain, and which actually opens the ability for participants kind of to decide that they also want to become a node in this blockchain. We mentioned the consensus methods, the verification of the transactions in a block as valid already. There are a number of them, and they're pretty much depending on the individual protocol. Then we have a permission versus permissionless blockchain. So that is very, very closely related to the private and public one, actually. If I need an authorization for participation in or having access to the blockchain, that's a permission blockchain versus a permissionless one, where access in itself is possible by anyone for participation. And the last point is there are different ways to prove mechanisms to prove whether the right to add the transaction in itself is valid, and that follows a certain level of randomness, whereby nodes which would be able to add blocks to the blockchain, and by doing so adding transactions to the blockchain, are selected on a random basis. And so the most popular one, or the most known one so far, is the one which was introduced with Bitcoin, a proof of work, where a mathematical problem had to be solved. But there are other ones. So for example, proof of stake, which is recently the method which Ethereum picked up, which is a lot more energy efficient, and therefore kind of from an SDG perspective, a more favorable way to do it. So I would like to go now to one question, which is, how is blockchain actually understood by businesses? And there are 3 viewpoints I would like to give. The first one is the one which follows now, kind of like blockchain are seen by the public in general that it is crypto. There are NFTs. There's a lot of hype around it. And you have effectively digital images of apes or whatever, which are sold then for certain amounts of money, and it's a kind of like a business model which is based pretty much on tokenomics, on selling of tokens and funding effectively projects that way. But that's not the way we show our clients blockchain. We are kind of taking the step from the bottom, from the Web3 Foundation, where we kind of then on top of that have digital distributed ledger technologies, an ecosystem of layer 1 and layer 2 blockchains. Layer 1 are original ones, and layer 2 are then blockchains on top of blockchains. And then effectively it goes to the application layer, using decentralized digital identities and empowering and enabling then applications in the areas, for example, of supply chain organization, sales and marketing, and giving additional or alternative ways to deal with identity and access. And all of this is actually also a foundation to use artificial intelligence in a responsible way. Heinz mentioned that already. Kind of deepfake costs are dropping almost down to 0. And what was in the past kind of like believed to be true due to the fact that I looked at a picture and I could see, okay, the picture is an original that is gone. So we need other means and methods actually to verify whether what is presented to us is actually the truth.